From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donn Felker.
And I'm Kaushik Gopal.
Welcome to the show.
I'd like to thank Square for sponsoring today's show. We all know Square to be a company that's one of the best stewards of open source in the Android community. But what some of you might not know is that they also have a pretty solid presence in the developer community at large. Just recently, they started a new YouTube channel just for developers at youtube.com/squaredev. And the YouTube channel looks pretty good. They have detailed videos explaining how one would use different SDKs like Python and Ruby to integrate their different products and services. And if you're curious about their different products and services, they basically have a bunch of APIs and SDKs to make taking payments easy. They also have payment forms if you want to quickly embed a checkout experience into a website. And not only that, Square supports iOS, Android, Flutter, and React Native for in-app mobile payments, or if you want to integrate their very famous Square Reader into your own app. Anyway, there's a bunch of stuff in their new developer channel. They're starting to add a lot of these tutorials and a host of other videos too. Check them out at the new channel, and that is at youtube.com/squaredev. So youtube.com/SQUAREDEV. My thanks again to Square for sponsoring today's show.
This episode of Fragmented is brought to you by Flatiron School. At Flatiron School, the students are parents, musicians, travelers, and working professionals from all walks of life. It doesn't matter if you're an entrepreneur running your own business, a marketer diving deep into user behavior, or just someone who loves design. It's time to level up your creative chops. You can design your future by learning UI and UX design at Flatiron School in just 24 weeks at one of their global WeWork campuses or even online. Their committed instructors have both industry and teaching experience and are backed by their master's teaching and learning experience designers to ensure that you get the best possible support. Now, while in school, you'll work on client projects and graduate with a portfolio of real client work. This will enable you to change careers with confidence with one-on-one support from their dedicated career coaches and with a money-back guarantee. Complete details about Flatiron School, you can go to flatironschool.com/terms. Again, that's flatironschool.com/terms. And join the community of changemakers at Flatiron School at flatironschool.com/fragmented. Again, if you're interested, check out flatironschool.com/fragmented. Today on the podcast, we're going to talk about TDD and testing in general. This topic was spawned from a tweet that I replied to by a follower who goes by the name of Laxman. So thank you for that tweet, and it kind of spurred a thread that I had written, and I wanted to expand on that a little bit. And originally, this came from a kind of a thread from Ron Jeffries. If you're not familiar with who Ron Jeffries is, he's a pretty important figure in software. If you're not, check him out. Lots of great wisdom he has, and he shares throughout the years. But his tweet was basically this. I'm going to read the quick thread real fast. It says, TDD, by which I mean the thing where you write a tiny test, see that it doesn't run, write just enough code to make it run, refactor the code to remove any duplication and add clarity, repeat until done. Why do we do that? One word, productivity. A few words, most cost-effective path from here to done. It's not about beauty, craft, a sense of pride, although it can provide those things. It's about using the most productive approach to getting our job done. Why, you might ask, is it the most productive way? I'm sure it does feel slow. Let me count the ways. 1, the code always works. We're never in a state where the thing almost works and we're not quite sure why it doesn't always work, or not quite sure even whether it works at all. 2, the code is well designed and it helps us go fast. We can deliver more goods faster over a smoother road, over one riddled with potholes and detours. TDD keeps the road smooth. 3, we can find what we need rapidly and change it easily if we need to. Everything appears once and only once and is cleanly separated out. modularity works, speeding our reading and adjustment of the code. 4, that's not slowness you feel, it's smoothness. The faster driver, the fastest runner, the fastest swimmer is, above all else, smooth. No wasted motion. TDD keeps us from wasting motion. Add your own observations and think about them. TDD is about productivity. It's about delivering the most working code per unit time and unit dollar. Currency conversions provided elsewhere. TDD is about time and money. It also feels really good. Now, the reply to this was from Laxman was, great thread, but I'm not sure how to always write tests before the actual code. I actually write tests before and after for logics that I'm confused with, of which will be hard for me to test manually, but writing tests for everything has been tough. So basically what he's saying is sometimes I don't know what to write tests for, or I don't know how to write the tests or whatever, and he asked for some advice here. And so I actually replied to him in a thread. And so here's my thoughts on this is, I think this is a paradox in which we can find ourselves all in at one point as developers. And that paradox is, how do I know what test to write if I'm not sure what I'm doing? What if I don't even know how to write the code yet? How do I even test it? So let's run into this example here. Maybe I need to write some code that allows me to take some video streaming and take that stream and push it up to a server somewhere or something like that. Or maybe I just need to write it to a particular file system. Let's go with that code. It's easier. And we need to write a file to the file system for whatever reason. And I just don't know how to do that for whatever reason on this new, programming language I'm working in. Could be Kotlin, could be Android, whatever. So what do we do at that point in time? Well, we do know when we write this code that there's going to be a result that we can test, right? There's going to be a result of that code. It could be a return value, it could be a side effect. In our case, it could be a file. In other cases, it could be a web page or a mobile screen. We do have some type of side effect that's going to happen. But what if we don't even know how to code it? Well, in that case, that's where a spike comes into play. Now, for those of you who are not familiar with what a spike is, it's just SPIKE. A spike is a product testing method which kind of originated in extreme programming. And essentially, you use the simplest program possible to explore all the different types of implementations you could use. In other words, you just fire up a test project and you try to get it to work. You don't worry about making the code pretty. You don't worry about writing the test for it. You kind of spin up something in a little sandbox environment. Say, all right, let me play around and see how the various ways I can implement this particular solution is. Now, it's used to determine how much work is going to be required to solve a workaround or a software issue. And typically a spike test involves gathering additional information for testing or finding weird edge cases and so forth. And this is really developed early on in agile software development, in things like extreme programming and Scrum, and used in Kanban and stuff like that too. So anytime you need to do something and figure something out, what I like to call it is just a spike. I don't know how to write that code. Let me go spike it out in just a test project and see how it works. And as soon as I figure that out, I can kind of get to the point of like, all right, well, what's next? Well, now I need to figure out how to test that code once I figure it out. And so I need to investigate the best level of testing that's going to support what I'm going to be testing. Because remember, our original question is, what if I don't even know how to test the thing that I'm going to write, or how do I even write that test? Well, at that point, if we already know how to write our code that we need to test, we're past that problem. But we still need to be able to write a test for it. At that point, we have to figure out what type of test. Is it going to be an integration test? Is it going to be a unit test? Is it going to be a system test that wraps the entire system? I don't even know. If perhaps the value updates a value on a screen or a web page, maybe we could just do a UI test. If it perhaps affects some type of variable, we could just return value. If it's a method or a class, I might use a unit test. But that's if dependencies don't become a nightmare. We've all had those weird classes that kind of have like these strong dependencies through singletons to 40 other classes. And as soon as you try to test it, it's like, oh, I can't find the Android application context, and I can't find an activity, and everything just kind of starts breaking. So at that point, if we run into those weird situations here, then let's say we run into situations where everything's super tightly coupled. There's no test. At that point, we probably need to just write a whole UI test. But now what if you don't know how to write a UI test? Well, then again, we go back and go to another spike, fire up another test project, do a little hello world thing that puts hello world onto the screen, figure out how to test hello world. Do something simple, get familiar with how to write that UI test, then come back to this problem. So now finally, once you've got that figured out, you'll go write your UI test kind of that asserts that code change. Now, the key thing here is to remember that once you get that under test, it doesn't mean you're done. What you need to do here is now follow kind of the red-green refactor. And what red-green refactor means, we need to see it fail, then we need to see it pass, and then we need to refactor the code, clean it up, remove duplication, all that kind of stuff that Ron Jeffries said before in the original tweet. Now, a lot of times people will write tests and it'll be green and they're like, it works, perfect, move on. Now, here's the thing. If you never see a test fail, how do you know it ever worked? Kind of a good question, right? So I always forcefully will make my code, fail a test. And I'm more than a handful, many times, I have written a test intending for it to fail and it passed. I'm like, whoa, what's going on here? And usually at that point, I'm using maybe the wrong assertion. I'm checking for the wrong thing. I'm using the wrong screen. Something is wrong that I need to investigate because I need to see it fail. So that's the first thing first. Purposely make it fail, then fix all that code after it fails to make it pass correctly. So, and then once you get your UI test, you can kind of clean it up, go back and start removing some duplication and stuff like that. So let's kind of step back again. Now, what if it's not a UI base? Like maybe you don't have a UI to test. Well, then we need to know how to write some type of unit tests or something like that to test it without a UI. Again, if you don't know how to do that, it's time to go back and do another spike on how to do certain types of unit tests. With Android, if you've already written an espresso test, you're kind of already familiar with how to write a unit test. It's just, instead of testing the UI, you're testing a return value or something like that. Now, again, once you have it, go back and write the test. So at this point, you start running in usually to the same problem we discussed before. What if that unit test has too many dependencies and it's hard to test? Well, if that's the case, you can go back to the system test. And what that means is, let's assume we're testing that file or whatever here. So our output is a file that's on the disk. Maybe it's on the SD card of the Android device. And we want to check to make sure that file is run or whatever. So we need to be able to write a test for it. So what we can do is we'll go actually write our test inside of our actual espresso test. We'd write the test. The file may be generated in a particular location that we expect it to, and we can write a test around that. Say, all right, it's generated this location. Now, it's not a great way to do it. The test may be super clunky. It may be not very hermetic, which means I can run it once. If I run it again, it's going to fail. It's not very repeatable. But at least right now, it's a test that validates behavior. And what that means is I can write this test. I can execute the code. The test will pass. It validates that the file is on the disk, and it works great. So now the next thing is I need to start refactoring that. So, for example, how do we refactor something we're testing to see if a disk is on the file a file is on the disk? Well, can we refactor this to use like an in-memory file store during the test environment? So instead of writing a real file, we just put it into memory, and I can check that this fake memories, this fake disk is putting it in memory and it works. Okay. Perhaps that we can't do that. Maybe we need can we write to a temporary file using the Java utils or Kotlin utilities to write a temporary file, and then can I clean it up before the test or after the test is run so everything's more hermetic? And then continually, how do I make this test over and over and over? Now, the thing that I think a lot of people get hung up on is that first test, is getting it to first pass. Remember I said, maybe I just want to see that the file is in a particular location in my Android SD card or Android storage, whatever it is. And if I run it once, it'll pass. If I run it again, it'll fail because the file is already there. Okay, that's fine. Now you have to remember, your first test doesn't have to be pretty or nice or great. In this case, until you can start refactoring right away. That first test, it writes the file. Now you may have to go into the actual, ADB and delete that file by hand, but at least you can run that test again. And if you do that and it continually is passing after you delete the file, of course, well, now you have a repeatable test that you can start iterating off of. And eventually the first thing you do is all right, we need to figure out a way to clean up this file immediately without me having to do this so I can make it more hermetic. But the thing here is that you have a test. It's not, it's not great. It's not pretty. It's not nice. And in fact, it'll often be a very disgusting looking test. And especially if it's an old legacy system, but at least now you have a test where you didn't have one. So now it's just time to improve it. So the goal really here is just to keep improving, follow that red, green refactor. And right now we're in the refactor part. And again, maybe this UI test or system test is super slow and it's super clunky. Maybe it takes a long time to run. So what? At this point in time, now you have a test again. You can refactor that code. Maybe you can clean up some dependencies. Maybe you can make it work better. Maybe you can make it faster. That's now your next task to help speed that up. Or maybe it's not. Maybe it's okay if it runs, it takes a couple minutes to run, whatever. You can make that decision at that point in time. But now because you have that test, you now have basically a nice safe area where that code is safe and it continually can run and so forth. So what's the underlying message that I'm really trying to get at here is that if we go back to the original question of I don't know how to write the code for this test, and I don't even know how to write the test. The underlying message here is you have to be learning. Always be learning. You need to learn the framework. You need to learn the language that you're working in. You need to learn the test tools. You need to learn the environment. And the more you learn, the more efficient you become and the better you become at it. I've been coding for over 20 years now, and I still run into countless situations weekly where I have to spike things out in new languages and frameworks. And this just isn't for Android. I've been doing Android for over a decade. There's still things in Android where if you came to me tomorrow and said, hey, Donn, I want you to build something with the work profiles in Android. I want to do X, Y, and Z. I've never done that. I'm going to have to go figure that out. I'm going to go spike this out in a test project, figure out how to get it working, figure out how to write a test for that, and then I'm going to start kind of putting everything together. Now, doing this, I can write tests for any of my code. It could be, again, Android, some other language. And when you write these tests, I like to think of them as an island of safety, like a big ocean. The ocean's very dangerous. Where's the safe spots? Islands, land. If I go on a land, I should be kind of safe. If I'm just floating in the ocean, it's a pretty dangerous place. Just float by yourself. Each test that you write is like a new island popping up in the middle of the ocean. So the more tests you have, the more safe spots you have inside of your ocean, which is your code base. And I know that any of that code that's tested can be safely refactored and can be relied upon. So to wrap up here, what we really want to say is you should always be iterating on your projects and your code and your learning and everything. And the big thing here is be humble. Don't let your ego get in the way. Like I said, I've been coding for 20 years. Sometimes this stuff does get frustrating. That happens to me too. I just want things to work. I get impatient. But try not to let your ego get in the way. And I try to remind myself of that. Don't let my pride or my ego get in the way. Sometimes I don't understand things. Sometimes I don't know why this framework does this thing in this way, or this testing framework does this. It doesn't make sense to me. It's okay. Try to be humble. If I don't know how to do something, I try to approach it with a curious wonder and a beginner mindset. Remind yourself of when you first started coding. What's some of the first things you did? Maybe you made a web page with like a little blink tag and you're like, that's cool. That was fun. You can remember that feeling that it gave you internally of like, wow, I really enjoy doing this. Try to go find that curious wonder and that beginner mindset again. If you do this while you're writing your test, while you're writing your code, and you're learning how to do this, you'll have fun and you'll enjoy it more. I hope that helps. We'll talk to you next time.
I want to take a quick moment and thank our sponsor for this show, Square. Head on over to their new YouTube channel just for developers at youtube.com/squaredev. That's the new channel where they talk about integrating a lot of their APIs and services. They also have some pretty cool videos on developer topics in general. I checked out this site and found myself watching their developer video on idempotency. It's a pretty cool video, so you should check it out if you're curious about the topic. Anyway, my thanks again to Square for sponsoring today's show. Please do check out their new YouTube channel, and that is at youtube.com/squaredev. So SQUAREDEV. Thanks again, Square.
Flatiron School is a sponsor of Fragmented. At Flatiron School, you learn how the future is being built so that you can change anything, starting with a new career in UX and UI design. To learn more, you can go to flatironschool.com/fragmented. Again, that's flatironschool.com/fragmented.
That's it for the show, folks. Fragmented is hosted by Donn Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.